Hi, my name is Anders. I am the Business Development Director of CorPower, and we produce wave energy power plant. And the reason why this is so interesting is the fact that about 10% of the global consumption is easily accessible along the coast of the globe. And that is twice as much as the total installed nuclear power that we have today. So it is a massive resource. So why hasn't this been done before? Well, it has, but no one has really succeeded yet. And the reason for that is, as you probably have seen just during the last couple of days, the nature can be quite harsh. It's a very fierce environment. And what we need to do is to be able to survive and still generate revenue to our customers. So the way we do that, if we start off with the buoy that actually oscillates in the water, it's a composite buoy, so we get rid of corrosion on the material. And the interesting part about this buoy is that it's actually designed to be a very bad point absorber, to absorb very little energy from every incoming wave. But in order to produce a lot of energy from it, we have added a couple of innovations to it. So this is a dry test hill rig here in Stockholm, where we produce electricity to the grid. And in here, we have three innovations. The first one is a pretension system. So what we actually do is that we pull down the buoy into the water column. And by doing that, we can decrease about 40% of the weight. And that is capital cost. And what we also get is a very good controllability of the device because we know where it is. And we also get a way to survive or to take off peak loads when big waves are coming in. The second thing that we have in here is something called a Wavespring. And Wavespring is a negative spring. And what that does is that it gives us ability to work in a wide bandwidth. So I'll come back to that, what that actually means. And the last thing that we have is a cascade gearbox. And what that does is a very effective way to transform the linear motions that we get from the waves into rotating motions at high speeds. And what that does is that it decreases the size of the generators and therefore also the cost for the generators. So what we get is a resonant wave energy converter. And what that means is that waves from the ocean is similar to radio waves. And if we can tune in or tune out in every incoming wave, that means that we can optimize the power output in normal sea states, or we can tune out when we have big storms. So we have a power plant that can survive the largest storms. We can now simulate up to 30 meters wave height in our hill rig here in Stockholm. And when we tune in, we get a very effective or efficient power plant. So that means that we can produce electricity at a very competitive price. And what's interesting with wave is that it has a different timing compared to solar and wind. So what that means is that we have access to probably the largest storage, the largest battery in the world, because we can produce power when solar or wind is not producing power. So therefore we add two values to our customers. Both we can produce electricity to a low cost, and we can produce it to different timing. So if we look into the pure physics of it, we can produce 3 times more energy per PTO force, or 4 times more energy per ton. And this is the same structural efficiency as the latest wind power plants have. And wind power has taken about 35 years to get to this structural efficiency. And this is our starting point. So when we look at that, we actually see that we can get to a levelized cost of energy that can be competing with current technologies. So we've been doing this for the last 7 years. We'll ship our power plant to Scotland in a few weeks and install it there and do continuous testing on it. But the overall sort of short-term goal is to reach a bankable product by 2022. So it's a 5-year program, but by 2022, that means that we have a product that is underwritable, it's insurable, and our customers can acquire debt to actually build farms with this. And we have a couple of customers who are already interested in this, and we have a couple of projects. One of them is already consented. It's a 10-megawatt site in Cornwall. And then we have 2 additional projects, one in Ireland and one in Wales, that this company are developing for our technology. So developing new type of energy generating systems does cost quite a lot of money. So we are looking at 46 million euros to take this from where we are today to a bankable product. But we are very fortunate because we are in an area which is on the strategic agenda for the EU and for national governmental agencies. So we think about 75% of this funding will actually be non-dilutive or non-equity funding. And we're currently raising 4 million euros during the fall. So if you have an interest, obviously, we are very interested to speak with you. So why will we succeed when so many others haven't? Well, we have the most efficient wave energy converter that can survive the biggest storms. We have a number of countries who are actually now fighting over us to come to them and develop this so we can get additional funding. The EIB, the European Investment Bank, have a committed program for wave and tidal energy. So there is a significant amount of funding available to do this. And we have already committed customers who are publicly saying that they have evaluated 200 wave energy technologies and saying that this is the best that they have found. And obviously, we have a very dedicated team who have done this before. So thank you very much.